In this next problem, we're dealing with a pile of grain, and it's falling from a conveyor belt or whatever at a rate of 10 meters cubed per minute at a constant rate. And it's falling in a pile that's shaped like a cone. So let me draw that here. So you got a cone-shaped pile, and let's see here. So this grain is falling at a constant rate of 10 meters cubed per minute, and so the pile is getting bigger. But the height of this pile, this is the height here, is always going to be 3/8 of the diameter of the base. So this is like the base here. We'll call that B. So this is always 3/8 of B. Okay? And so, but the pile is getting higher, and what it wants to know is what is the rate of change of the height of this pile when the pile is 4 meters high. Okay? So the idea is this pile is getting bigger as this grain is being added, and it's being added, so the volume of this cone is changing by this amount. So like dV dt is always like 10 meters cubed per minute. Okay, that doesn't change, but the pile is getting bigger, so probably the rate at which the height increases is going to slow down as the pile gets bigger and bigger, because it's a constant amount of grain being added the whole time. And so it wants to know what's the rate of change of the height. Okay, so we're going to use the volume of a cone here. And that's going to relate these things together. So the volume of a cone, and you can look at this in your textbook or whatever online, but it's 1/3 pi r squared h. And so r is the radius of the r is going to be the radius of the cone, okay? And so what I want to do here is I want to find the rate of change of the height here when the pile is 4 meters high. So what I'm going to do here is I would like this whole thing to be just in terms of V and H, okay? Because I don't know anything about the rate of change of the radius here, but I do know about dV dt, okay? And so what I need to do is I want to get R here in terms of H. And that's not going to be that difficult, because R here is just equal to half of B, right? Or I could just say B is equal to 2R, right? And so H here is just going to be 3/8, and then I put in 2R, right? Like that. And so that would just be like 3/4 R. So the height is 3/4 R. So what I want to do here then is, okay, I want to place, okay, I need to solve this for R is what I need to do. So R is 4/3 the height. So I'm going to place this in for R into this formula here, and then everything will be in terms of H. Okay, so when I do that, this is 1/3 pi, and then in for R I put 4/3 H, and then I have an H here. And that'll be squared. So this is the R squared, and then I multiply all that by H. So here's a formula relating V and H together, and then I'm going to be able to do the implicit differentiation on this, and then I'll have, I'll have dV dt, and I'll be able to find, and I'll have H here, which I want to find, and I'll have a dH dt, and I want to find dH dt when H is 4. Okay? So let me I'll even write that. We want to find dH dt when h is equal to 4. Okay, so let's simplify this then. So this would just be v is equal to like pi over 3, and this would be 16 times 9, and then I'd have an h squared, and that'd be h cubed. And then I could simplify it one more time. Let's see, 16 pi over 3 h cubed. So that simplifies it down kind of nice. So now I'm going to do the implicit differentiation. So this side would be dv dt, and then this side I'll bring the 3 down, and that's going to and this, when I multiply this together, this should have been 27, right? So I'll bring the 3 down, and that'll make this 16 pi over 9, and this would be h squared. And then I have a dh dt. And what I want to do is I want to find the rate of change, dH dt, when h is 4. Okay, so I'm going to solve this here, dH dt, and I'm going to have dv dt, okay, on top, and then I'm dividing by all of this. So I have 16 pi over 9 h squared. And now I can put everything in here. I'm going to find dH dt. I'm going to put in 10 for dv dt, 4 in for h. And so when I do this, so my dH dt when h is equal to 4 is going to be 10 over 16 pi over 9, 4 squared. Okay, so I just need to figure that out. And so, get my calculator here. When I do this, I get, I'm going to get 10 divided by, and then all in parentheses, I'll have 16 pi divided by 9, all that times 16, and I get this here. This is like it's like 0.1119, and this is meters cubed, or just meters, sorry. This is meters per second, and it wants it in this is the rate in meters per second, and wants it in centimeters per second. So my final answer, I just move that over to, it'd be like 11.19 centimeters per second. Okay, 100 centimeters in a meter. Okay, so that's going to be the rate of change of the height of this pile. And you know what? This is not per second, is it? This is per minute. So I need to change that. M-I-N. This will be the same. M-I-N. So it's 11.19 centimeters per minute is the rate of change of the height of the pile. Okay? So now what I want you to do is I want you to find the rate of change of the radius of the pile at the same time. When the pile is 4 meters high, can you find the rate of change of the radius of the pile? So go ahead and press pause and see if you can find it, and then if you think you got it, go ahead and you can resume the video and see how you did. Okay, so now let's give this a try here. I'm gonna do this on the back. So I want to find the rate of change of the radius. So I'm wanting to find dr dt when h is equal to 4, right? And this is h. And remember, h is, we actually had a nice formula in terms of r. H is 3/4 r. So I'm going to use that, 3/4 r. That'll be h in terms of r. And so now the volume of this cone is 1/3 pi r squared h. And now I want everything in terms of r, because I want to find dr dt when h is equal to 4. So I want everything in terms of r. So this is 1/3 pi. This is going to be r squared, and then in for h I get 3/4 r. So it'll look like that, and then I can move this over. The 3's cancel out, and I'm going to get like pi. This will be like pi over 4 r cubed. Okay, so this is what v is in terms of r in this case. And so now I'm going to take the derivative of both sides with respect to t. So dv dt is equal to, bring the 3 down, 3 pi over 4, and then I'm going to have r squared, and then I'm going to have dr dt. And I want to find dr dt when h is 4. So what I need to know here, when h is 4, what is r going to be, right? So this would be 4 is equal to 3/4 r. And so r is going to be 16/3. So that's what r would be. So now I'm going to solve for dr dt, and I'm going to get dv dt all over the 3 pi over 4 and 3 pi over 4, and I have the r squared. So, well, I'll write it like that, r squared. Okay, so now I want to find dr dt when, we'll say when r is equal to 16/3. And so the top is 10 still, and then I get 3 pi over 4 16/3 squared. Okay, let's see what I get. I hope this works. 10 divided by 3 pi divided by 4 times, that would be like 16 squared divided by 9. And yes, that looks familiar. That's what I should get. So it's like 0.1492 meters per second, and it wants it in centimeters per second. So just move the decimal point over 2 places, centimeters. And I'm sorry, again, it's minute, not second. So centimeters per minute. So that means the rate of change of the radius of the cone is 14.92 centimeters per minute. Okay, so we found both the rate of change of the height of the cone and the rate of change of the radius of the cone using the related rates, and the volume is the formula relating those things together. What made this one a little bit different is I had 3 variables going on in the original formula, right, in this formula, and when I did it, actually did the problem here, one of these variables is related to the other variable, and so I'm able to put it all in there so that you just have v and the variable that you're interested in. Okay, and that was necessary. You needed that relationship. Otherwise, you would have needed to know something about the rate of change of the other variable. I would have had to know, in like this one, I would have had to know the rate of change of r in order to find dh dt. Okay, but since they were related together, since the height was 3/8 of the base, which the base is just twice the radius, then you're able to do it with just the rate of change of the volume. So, yes, okay, so another nice problem there. So, we'll do some more.